Okay, so now let's talk about the Amazon ECS Elastic Container Service. And first, what is Docker? First thing that comes in mind is the Docker. So because Docker is at the center of ECS, Docker is a software development platform used to deploy apps, and apps are going to be packaged in containers, and these containers have the specificity that they can be run on any operating system. So apps will run in the same way regardless of where they are run. That means that any machine can run a Docker container. There will be no compatibility issues, and you will have predictable behavior. That means less work. They are easier to maintain, and it works with any language, any operating system, and any technology. Thanks to the Docker, we can control how much memory and CPU will be allocated to each container, and then that allows our container to use just the right amount of resources. These containers can be scaled up and down very quickly within seconds. So this all of the features that is available to us as a container management system. So thanks to the Docker management system. So they are therefore for writing applications more efficient than the virtual machines. So Docker management, Docker container management on AWS here can take several forms. We need a container management platform, so we have either ECS Elastic Container Service, which is which is Amazon's own container platform, or we can use EKS, which is Amazon Elastic Kubernetes service, and this is Amazon's managed version of the Kubernetes. And Kubernetes is an open source software that's widely accepted for managing Docker containers. And then we have Fargate, which is Amazon's own serverless container platform, and it works equally well with ECS and EKS. So let's now do a deep dive into ECS. So ECS, the use cases are to run microservices. For example, to run multiple Docker containers on the same machine, or to have service discovery features to enhance communication between these microservices. We have a direct integration of ECS containers with the application load balancer and the network load balancer. We have auto scaling capabilities. It's also very helpful if you wanted to run batch processing or schedule tasks, or also you can schedule ECS tasks to run on demand, on the reserves, or on spot instances. And then ECS is also very helpful when you migrate to the cloud-based cloud, because you first Dockerize your application running on premises, and then you move these Docker containers to run on the Amazon ECS. So the concepts you need to know for the Amazon ECS, uh, but hopefully this is not new. So we have an ECS cluster, which is a logical grouping of EC2 instances. We have an ECS service, which defines how many tasks should run and how they should be run. Okay, and we have the task definition, which defines what is the JSON form of the definition of the task to allow, and tell ECS how to run a Docker container. So it could be what is the image name, how much CPU, how much RAM, etc., etc. So the ECS task itself is an instance of a task definition running within a service, and the ECS task is actually running Docker containers. And then you have the ECS IAM roles. So you have two types of roles. You have the EC2 instance profile that is used by the EC2 instance, and that will be managed by the ECS cluster. So this EC2 instance is going to make API calls to the ECS service and send logs, etc., etc. But then for each ECS task, we can attach an ECS task IAM role, which allows each task to have a specific role. And these roles are allowing these tasks to make API calls to Amazon S3, DynamoDB, and so on. So if we look at all it in a diagram, we have a cluster here. We have a cluster here. we have an EC2 instance and we run a service A. We need to provide a task definition, and when this task definition is instantiated, then we are going to get containers running on the EC2 instance for that specific service. So it's possible for you to scale the number of EC2 instances you have, so we can add one or more and one or more and one there, and then the service may place also ECS task onto these EC2 instances. Well, because we have multiple EC2 instances, we can have as well as an auto scaling group that will manage these EC2 instances, and we can and to make sure that these are part of an ECS cluster, we need to define an EC2 instance profile that will be allowing our EC2 instance to be registered to the ECS service and also send logs to the CloudWatch logs service. Now, in case my service and my task within my services need to access, for example, on these three buckets, for example, on the S3 bucket, then we need to make sure to provide the task IAM role for my task within my service. And if you wanted to have a second service within your ECS cluster, you could as well as third and fifth, you could as well as third and fifth, etc, etc. So for us, and so each service will have different tasks and it will be replaced all along your available EC2 instances, and if there is a space for them. So then Amazon ECS has a great integration with the application load balancer. So for this, it's called the dynamic port mapping feature, which allows us to run multiple instances of the same application, same Docker container on the same EC2 instance, and the ALB, even though each container will have a different mapping port, is able to find the right port on your EC2 instance and map it to the load balancer. So let's have an example. So we have an ECS cluster running one service, and we have 4 tasks across 2 EC2 instances. And so as we can see, each EC2 instance has so this is the ECS task, and the bottom one is the ECS cluster been written there, has been actually been hidden from my view. So now ECS cluster running one service, and we have 4 tasks across 2 EC2 instances. So so as we can see, each EC2 instance has 2 of the same task, and now we have users accessing our application through our load balancer. Okay, so that's good. And so each ECS task is going to get a different port. So the first ECS task is going to get this port and we gonna have to thank for the dynamic port mapping feature for this. And then the second ECS task is going to get a different port, but the ALB application load balancer is here smart enough to find it as well, and so on. Even though the port is not stable across all my Elastic Container Service tasks, because the service of ECS is mapped to the ALB, this dynamic port mapping feature comes in, and then ports are mapped gratefully. So in terms of use cases, you get increased resiliency, because even if you are running on one EC2 instance, you can have multiple Docker containers running on it. You are going to also maximize the utilization of your CPU and your cores on your EC2 instances. And if you want to perform rolling upgrades, you can do it, because now you have many Docker containers, ECS tasks, and on the one instance, and therefore you can take them down one by one without impacting your overall app uptime. Okay, so we have seen ECS and the EC2 instance, and so we have to provide EC2 instances ahead of time to run ECS task on them. But it is possible for you to launch Docker containers on Fargate serverless. And with Fargate, we do not provision the infrastructure. There are no EC2 instances to manage. Instead, it's all serverless. We don't even know or see that there are some background hardware. So how does that work? Well, the Fargate service runs on ECS, and you can submit Docker containers to a Fargate service, and the ECS tasks other than Fargate are going to be created automatically without you having without having you think about the EC2 instances at all. So you just create task definition, then you specify how much CPU and RAM you need as per the task, and then you will be and the task, and then they will be created for you. And if you need to scale, just increase the number of tasks simply. You don't need to manage any EC2 instances in the backend, which makes it very convenient way of running ECS services. Now, in terms of security and networking, so you can inject secrets and configuration as environment variables into the running Docker containers. So there is deep integration with the SSM Parameter Stores and the Secrets Manager service. And you also need to know about the different ways to do networking on ECS task. So the first one is none, okay, which gives you no network connectivity at all to your task. No port mappings. Bridge will use Bridge will use Docker's virtual container based network. Host will just bypass Docker network and will use the underlying host network interface. And then AWS VPC, which is a special one, is going to make sure that every ECS task launched on the instance will get their own elastic network interface and their own private IP address, and it's going to give you simplified networking, enhanced security groups, monitoring VPC flow logs, and then it's going to be the default mode for even the Fargate tasks. Okay, so next for Amazon ECS, we have service auto scaling. So this allows you to automatically increase or decrease the desired number of tasks of your service. And so for it, in the backend, the ECS service is going to leverage to Amazon, the AWS application, auto scaling service. So other general facts like the CPU and RAM are tracked as metrics in CloudWatch at the ECS service level. And so therefore we can set up target tracking to scale based on the target value of a specific CloudWatch metric, or we can set a step scaling, or we can set up schedule scaling, and so on, just like you would do for the auto scaling group, but this time for an ECS service, elastic container service. So even though you can auto scale your ECS service at the test level and it works really great, if that ECS service is not running on Fargate but it is running instead on EC2 instances, then you should make sure you also auto scale your EC2 instances to add more capacity to your ECS cluster. Therefore, Fargate auto scaling is much easier to set up because it is serverless and we don't need to think about the underlying resources to run your auto scaling. Okay, now next we have Spot instances. So Spot instances work on ECS. So for ECS Classic, the EC2 launch type, then we have underlying EC2 instances as Spot instances managed by an auto scaling group. And in case the Spot instances are going to be removed, then they may go into draining mode, which is going to remove the running task and move them over to other instances. So it's good for cost saving, but it can impact reliability because we are using Spot instances for the Fargate type. We can also specify a minimum number of on-demand instances within Fargate. So on-demand task, but we can also add tasks using Fargate Spot for cost saving. even though we know that again, because there are spot instances that can be they can be reclaimed by AWS. So regardless of an on-demand or a spot, Fargate is going to scale really easily and well based on the load you will provide to those tasks. Now finally, to store these Docker images, we have Amazon ECR, Elastic Container Registry. So to store and manage Docker images on AWS, you have a private registry repository. So for your own accounts, but also public repo in case you wanted to share some images publicly. And so your repo is going to have multiple Docker images. Then in case an ECS cluster needs to pull that image in onto EC2 instances, then thanks to the IAM role of the EC2 instance, they can pull images from the ECR repository and run them as ECS tasks. So we have deep integration with the Elastic Container Registry and Elastic Container Service, and there is access control through IAM. So in case you get permission errors, then it should be an IAM policy issue. Now it's possible for you to pull obviously images from the repository or the repository B, repository A or repository B. So Docker image A, Docker image B. And the ECR is really cool because it supports image vulnerability scanning, versioning, image tags, and the image lifecycle. Okay, so that's a lot on the ECS. I know, but this is necessary for the exam to go through this all. Hopefully, by now you should know everything. I hope you liked it, and I will see you in the next lecture.